Okay, let us understand what is Foucault pendulum. Foucault pendulum is a heavy bob hanging from a long wire mounted to swing very freely in any direction. The Foucault pendulum is used to demonstrate our Earth is a non-inertial system. Okay, let us understand its motion and all. Okay, let us consider a pendulum. A pendulum which swings with a frequency gamma is given by root g by L. It's our simple pendulum, where L is the length of the pendulum. Okay, this is our figure. Here, this is the Earth surface. This is the center, and this lambda is the latitude, and this is the horizontal plane. In the horizontal plane, I fixed a pendulum like this. The pendulum make an angle theta with the tangential direction, and the r is the radial distance by which the bob moves. The bob of the pendulum moves. R is the radial distance by which bob of the pendulum moves. Okay, so r theta. So as I use r and theta, you just immediately remember we are going to use polar coordinates, right? Okay, so here the position or instantaneous position of the bob of the pendulum is given by r is equal to r0 sine gamma t. So sine gamma t means it is an oscillatory motion, where gamma is the oscillating frequency, t is the time, and r0 is the amplitude. As you know, r0 is the amplitude of the motion. Okay, so if there is no Coriolis force, what happens? There is no tangential motion. Okay, it will simply oscillate, right? And means theta is a constant, a particular constant value. But if there is a Coriolis force, the Coriolis force is horizontal, and the horizontal Coriolis force is given by minus 2m omega sine lambda r cap cross v. Okay, that is equal to minus 2m omega sine lambda v is replaced by r dot in the theta direction. So this is FCH, Coriolis horizontal Coriolis force, minus 2m omega sine lambda r dot theta cap. Okay, so therefore the tangential equation. So tangential equation is force ma theta is equal to FCH horizontal Coriolis force. We know what is a theta in polar coordinates. A theta is r theta double dot plus 2r dot theta dot. Therefore ma theta is m into r theta double dot plus 2r dot theta dot, that is equal to minus 2m omega sine lambda r dot. I'm not writing theta direction. Okay, so I cancelling m on both sides. R theta double dot 2r dot theta dot is equal to minus 2 omega r dot sine lambda. That is our required equation. We need a solution for this equation. Okay, in order to get a solution, I assume a simple solution that the theta dot is a constant. Theta varies constantly or uniformly. Okay, theta dot, that means theta dot is a constant, so that theta double dot is 0. So I can avoid the first term on the left hand side of equation 1. Therefore 2r dot theta dot is equal to minus 2 omega r dot sine lambda. R dot I can cancel, 2 I can cancel, therefore theta dot is equal to minus omega sine lambda. That is a required equation. So that means you know, here omega is the angular velocity and lambda is the latitude. For a particular point, latitude is a constant and omega for circulation earth is, we find it is almost fixed by considering earth as a perfect sphere, right? That assumption. Therefore the pendulum precesses uniformly in the clockwise direction. Why clockwise direction? Due to the minus. So we normally take the counterclockwise positive, therefore minus is this one again opposite that, so clockwise. So that means the pendulum precesses uniformly in a clockwise direction. So I have shown this figure how it precesses. Okay, so this one, so it will move from, start from here, goes there, then come back, then like that move, and so on. So the theta dot is the this one, how theta moves, theta dot. Okay, so now I want to calculate when it will finish one rotation. So it started here and when it will end here, that is one rotation. The time for the plane of oscillation to rotate once is called period. So therefore period t is equal to 2 pi by theta dot. Okay, what you have earlier known, t is equal to 2 pi by omega. Actually omega is theta dot. So therefore t is equal to 2 pi by theta dot, but our theta dot is minus omega sin lambda. I am just taking the magnitude, so negative time is not physical, therefore I am taking minus, avoided. So t is equal to 2 pi by omega sin lambda. So what is omega? Omega is this one, 2 pi by 24 hours. Okay, the one arc is 2 pi radian by 1 day, that means 24 hours. Okay, by substituting for omega and simplifying, you will get t is equal to 24 hour by sin lambda, that is the period. For example, at the poles, as we know, lambda is 90 degree, so period is 24 hour by sin 90. Sin 90 is 1, therefore t is equal to 24 hour. So 24 hour it will occur. So in all other if values, if lambda, for all other values of lambda it is different. Okay, so the pendulum rotates, clockwise with respect to the earth at the same rate as the earth rotates counterclockwise. Okay, this is the one method to demonstrate our earth is rotating and it is a non-inertial frame of reference.